notes, this is 4.2. We're talking about the number E. Now, if you look on your calculators, guys, there is a button that says, God bless you, that says LN. A lot of you see the LN button. And then above it is the E to the X power, okay? The natural number E is just, it's like pi. It's an irrational number that it's if I said to you, what's pi, you would tell me it's 3.1415, blah, 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 blah. There's a button on your calculator. E is the same thing. When we talked yesterday about interest rates and stuff like that, like with percentages and we calculated interest, this right here is the value of E. You can when you plug it in. This doesn't make any walking around sense to you guys. It doesn't matter to you. I understand that. But here is E. When you hit your calculator, this is the equivalent to E, 2.71828, whatever. Like I said, it's just like pi. So there's a button on your calculator. We're going to use it to evaluate. That's pretty much what we're going to do today. And then we're going to talk about some different kinds of interest problems. So if you have the natural exponential function, e to the x, like I said, it's on the button that says ln. They're inverses of each other, and we'll talk about that a little later. But it's just e to the x, where x is your variable. So we're going to evaluate where we're plugging in numbers for the x. If you look at a graph, the graph of e to the x is very similar. It's almost exactly the same as an exponential because it is an exponential function. It has a variable x in the exponent. You're just always using that base e, which is that 2.7 number, as the base. It never changes. It doesn't, like in our exponentials, we have 3 to the x. We have 5 to the x. Here, e is always going to be your base. Might be 2x, might be negative 2x, something like that, but e is always your base. So if you were going to evaluate, I want you guys to do this with me in your calculator so you can practice. It says to round to 5 decimal places. So that means you need to round to 5 decimal places. So you're in your calculator for like letter A. We're going to hit E, hit that second E button, and then I'm going to just plug in 3. So e to the third power, what does that give me? Do that with me, guys. What does that give me? And then hit the e to the third power, you get 20. If we're going to round it to 5 decimal places, it's 20.0855, and then it's 3/6, so it'll become 4. Okay, well, I'll just do this then. So then for B, I have 2, and it says E, and the caret button will come up, so you hit negative 0.53. So in my calculator, I'm going to hit 2, then I hit second, ln, the E comes up, and then I'm going to put negative 0.53. And I get 1.177 2, and it's 0.9. If we're rounding to 5 decimal places, that would become a 1. And then for C, it's e to the 4.8. So you're going to hit in your calculator second e, and then your little caret comes up, and then you put 4.8. And when we do that, we hit second e 4.8, and I get 1,215.51041. So if I give you something like that on a test or a quiz and you don't know how to do that in your calculator, you'll just get those wrong. So if you don't know how, if you're confused, if you're not sure what to do, send me a picture of your calculator via email and I can show you guys how to do it. All right, if you have a problem like this, guys, all they're doing is giving you a formula to plug in. It says an infectious disease begins to spread in a small city with a population of 10,000. After T days, the number of people who have succumbed to the virus is modeled by the function. They're telling you what the function is. It says how many people are there initially affected at time 0. For letter A, they're asking you, hang on one second, baby. For letter A, they're asking you to plug in for T equals 0. So in your calculator, you would do 10,000 divided by, and you have to put the bottom in parentheses. Please stop 1 second. You got to put the bottom in parentheses. So it's 5 plus, you would say 1, 2, 4, 5, E and then you'd raise that to the negative 0.97 times 0. Guys, what's anything to the 0 power? 1. Thank you. So your initial time, if you did this in your calculator, is 10,000. This whole piece right here, right? we'll say right here. E, when you raise it to the first, it's just going to be e to the first power is really what it's going to work out to be. So when you do this in your calculator, you can do it a couple ways. You can put it all together at once, or you can say 5 plus 1, 2, 4, 5, and it would just be e, because 0.97 times 0 is going to give me 0. Then I have e to the 0 power, which is going to be 1, right? So this would be 10,000 divided by, you would add, because this is 1, remember we just talked about that, 1245 plus 5 would be 1250. So in your calculator, what is 10,000 divided by 1,250? So 10,000 divided by 1,250. What'd you get, Soph? 10,000 divided by 1,250. Did you get 8? So initially, there's 8 people infected. So now they want to know, find the number of people infected after 1 day, 2 days, and 5 days. So what you would do is you would say, all right, after 1 day, so when t is 1, you would plug in 1 for t. So you would say 10,000 divided by 5 plus 1,245 e to the negative 0.97 power, because negative 0.97 times 1 is just going to be 1. So in your calculator, hit 10,000 divided by, and then parenthesis, 5 plus 1,245, second e, and you're going to raise that to the negative 0.97, and then close your parenthesis twice. And you get 20.96. So if we're talking about people, that's about 21 people after 1 day. So after 2 days, I'm going to do the same thing. I have 10,000 divided by 5 plus 1,245 e to the negative 0.97 times 2. So in my calculator, I'm going to say 10,000 divided by parenthesis 5 plus 1,245, second e, and then I have negative 0.97 times 2, close parenthesis, close parenthesis. Okay, I got about 54 people. So now we're after 2 days, we're about 54 people. Then at 5 days, okay, same thing. I'm going to put in 10,000 divided by parenthesis 5 plus 1,245 e, and now I'm going to raise it to the negative 0.97 times 5. And in your calculator, you have to close that parenthesis, then close the whole parenthesis. So 10,000 divided by parenthesis 5 plus 1,245, second e, negative 0.97 times 5, close, close. And now we're at 678 people. So you notice, guys, look, this is 1 day, this is 2 days, and this is 5 days. So see how quickly our exponential functions grow. It initially was 8 people. Then the next day it was 21. Then the next day it was 54. And then 3 days after that it was 678. So exponential functions, like I said, get big in a hurry. You guys need to pay attention to that. All right, when we talk about interest that is continuously compounded, right? Yesterday we talked about monthly, quarterly, daily. When they tell you something is compounded continuously, we use this formula, A per. I know you guys saw that in Algebra 2. I know I personally taught that in Algebra 2. You guys also saw that if you were in pre-cal, if you've had pre-cal. But A per, P is your principal, it's your initial amount. We've talked about this before. Initial amount, which you start off with. How do you spell initial? That's wrong. Interest rate, remember your interest rate needs to be in decimal form. Make sure it's in a decimal. And then the number of years is your time. So if you had Find the amount after 3 years of $1,000. Well, since it says continuously, you use the APERT formula. You don't use the one that we talked about yesterday with the 1 plus all that. So my initial amount is $1,000. Then I have my E, and I'm going to raise it. My interest rate is 12%, so that's 0.12. So it's 0.12 times how many years? 3 years. So in your calculator, you literally put it in just like that, 1,000, second E. I'm going to put 0.12 times 3, close my parenthesis. And I get $1,433.33. We use this formula when they talk about interest that is compounded continuously. I'll reference my old friend APERT. That's what we use for compounded continuously. All right, that's all I have for you for